Hi everybody. In this video we are going to explain the first experiment for separately excited DC motor. The objective is to find the relationship between the speed of the DC motor and the armature voltage. So I have the power supply, DC motor, and prime mover dynamometer and data acquisition. First thing we have to do the mechanical attachment between the DC motor and the dynamometer. The coupling will be through a belt. So we have to lower front panel for both, and then click on the shaft, drag it to the other shaft, then you need the belt. Then you raise front panel for both again to be safe. That was the first step. Second step, connect the 24 voltage to the data acquisition, and from the 24 on the data acquisition to the 24 on the prime mover or the dynamometer. Well, this is an old version. It needs 24. The new version doesn't need. So that's the second step. Third step, we are going to supply the field circuit of the DC motor. The field circuit here is 5-6, but you should connect the field winding to a rheostat, so you'll be able to change the resistance of the field circuit, so you can change the current in the field circuit. Now the terminal of the field circuit is between 5 and 8. You want to connect it to constant DC power supply, but I want to measure the current too. So we'll take from 8 to I2, and make the way clear here, and take the negative I2 to the first terminal of the field winding 5, and close the circuit by connecting 8 to the neutral. Now we measure the current. I know that it's not in the manual to connect a voltmeter to measure the volt in the field circuit, but I think, or I like to always have this good practice to measure the voltage also. So I connected E2 positive to the negative of I2, and the negative E2, and the negative of E2 to the neutral. Okay, now I'm done with the field circuit. I should move to the armature circuit, but I believe it's better when you finish a stage, check the stage is right or wrong. So I'll just go ahead and hit instrument, metering, and look at my meter for the field voltage and the field current. So I'll just go ahead and, all right, I did the power here. Make sure that this one is on. It's on. So I go for view, continuous refreshment. All right, great. So the voltage is 145.6 across the field, and the current is 0.187. I need to fix it at 200 milliamperes. So I just go ahead and just change the value of the rheostat step by step like that, like I'm doing, pressing the minimum. Okay, now it's 200. Oh, no, I'd like to get it like 200. All right, I got 200. So now I'm sure now I got the right ampere. Great. So I'll continue. I'll just stop, switch off the power, close this one, and I go to connect the armature. The armature, it is 1, 2. That's the armature circuit. So I connect it to DC variable power supply, 7 and N. So again, I want to measure the current first. So I connect it to I1. Just drag it a little bit here to make space for the negative, and negative I1 to the armature circuit, and 2, I complete the circuit to the neutral. First, do always everything in series. Now, the circuit is connected to the power supply, and the ammeter is set. Let's do the volt. How you measure the volt? Connect positive E1 to the negative I1, and the negative E1 to the neutral power supply connected to the armature circuit. Now it's connected. Before I start anything else, I just like to check, So what should I do? Let's see, we have continuous fresh. Oh, that's the armature, the voltage and the current. Well, I will click here and I just want to check if I move it, the voltage will it change or not. It's not moving, so it means there is something is not right. So, oh, the power. All right, okay, that's good. All right, and the motor start to rotate. Okay, turn it off quickly and return it back. So now I know everything is fine, everything is right. What should I do? Now, I mean, I need to measure what? I need to measure the voltage across the armature, current through the armature, voltage across the field, current in the field, and the torque and the speed. The torque and the speed, how you do that? Let's connect the torque from the dynamometer to the torque on the data acquisition, and the speed from the dynamometer to the speed on the data acquisition. I need everything here in data acquisition. Here the neutral, this white thingy, and then just connect it to the white ground here in the dynamometer. Okay, everything is set. Now we can start the experiment. What are we going to do? I'm going to change the voltage across the armature, this one, and then every time I'm going to record it. But record where? In the table. Okay, we need to have a table here. Let's look at the tools option. Oh, is not the one. Tools and data table. Yes, here you go. Then what's supposed to do? Go to option, record setting. You need the multimeter EA recorded. Yes, I need all this to be recorded. All right. Okay, here you go. I got the armature, voltage, field, voltage, armature current, field current, torque, speed. Great. Now, I mean, you have the first set. Everything is 0, right? Is it true? I don't have the power on. Power on. Okay. So I want to record the first set here. So I go to this icon for record data and I hit it. Oh, I got the first row. Great. All right. Just put it on the side here. Worry about it. Yes, on the side here. It's okay. Now, I will go ahead and change the voltage. That's the voltage meter. 10, is it 10%? I will just increase it 10 voltage, 10 voltage. How I do that? Go to the maximum, just click. Oh, you see, I mean, now it's happening here in EA. Till you get something close to 10. Maybe be over 10 a little bit, it's fine. 8, 9, all right. Oh, that's a lot, that's more. Let's take it back. Yes, okay. So you want to record this data. You go there and just say, hit, record data. Oh, the second row. It will be fast. It will take you 5 minutes exactly if you do everything right, step by step. Be patient. Now go back, maximum, increase. Observe the voltage here. You need to get closer to 20. 20. All right, 18. All right, 20. Okay, hit record data. Nice. You see, just quickly. Yep. Very nice piece of software. I like it. You need to get 30. All right, got 30. Record data. Oh, by the way, I mean, yes, I mean, you do that, but keep your eye on the speed. Once you hit 1500 RPM, you stop. Okay. But do exactly what I'm doing. I mean, you get nice curve. You'll see that. Be like straight line. All right. 40. Okay. It's like, I mean, 10, 10, 10, almost 10. Hit record data. All right. Be patient with me. But you got to make your own data. Don't take this one and copy and put it in your report. Don't. I know my data. Yes. Here you go. 51. Record data. All right. Good. The other one. Need to get more to 60. Yep. Getting closer. Yes, record data. I love this software. What we got? We got almost 1000. We are very close, very close. Be patient. Here you go. You need to get 70. All right, record data. Very close. By the way, you don't have to go to the full wave, full scale of the voltage in the armature. And that's the problem of some group they want to get the full and these exceed the speed or the current 80. Okay, record that. Of course, in software is safe. Nothing will be ruined. Even if you make mistake, it's safe. We need 90 volt, 90 volt, 90 volt. Okay, record data. Oh, okay, that's enough. You stop. We got 1500. You see, I mean, so you guys, when you do the hardware part, we just got 90 volt or 91. So I mean, so what I get, I mean, I should not exceed 90 when you do the hardware experiment. All right, I did that. You can stop the power now. You don't need to take any more measurement. You have the old measurement. You have EA, EF, IA. Okay, now what you want to do, you want to graph the speed against armature voltage. So you go for graph, hit graph, and let me just show something, because one student asked me, okay, well, how can I do that? You have x-axis. This is, I mean, when you make sample with number. No, you don't know that. You go to the line, and hit it. When you hit it, you should get x and y. This is x, this is y. X, you go for x and choose, that's the x-axis. The x-axis, you need to be the armature. Okay, y, you need the speed. Here you go. Straight line, perfect. Because you do 10 voltage every time. But I don't like, I mean, this color. Well, in this area, just by the right button, the mouse, and then you choose N. Click, this is N, and you do it yellow because you have green, so put yellow, be clear. Apply. Okay, all right. Here you go. You got it. So you got this one. And what's next you're supposed to do? Or what's supposed to do is just to find the slope, to find and the manual will be asked about the slope, to find K1, the factor, the ratio between the speed and the armature voltage. So simple, just to find any 2 points, like in the beginning there, beginning this one and this one, just get the slope. So we're done with the first part. I think it was helpful, and thank you.